Hello, in this video I'm going to solve the following problem for you. Evaluate the following integral. Integral x multiplied by tangent inverse x squared. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, the answer you will get is as follows. 1/2 x squared plus 1 times tan inverse x squared minus x tan inverse x plus 1/2 ln of 1 plus x squared plus a constant c. Okay, the first thing I will do for calculating this integral is to try to get rid of this tangent inverse here by introducing a new variable. So I would say let theta be equal to tan inverse x. And of course, the immediate consequence of this will be that x is tangent of theta. Okay? Okay, now I have to write everything in terms of new variable theta. So I need dx. So this motivates me to calculate dx. The derivative of tangent is secant theta squared, and of course I put d theta. Then I start writing my integral I in terms of the new variable theta. So instead of this expression, I put theta, so this becomes theta squared. So if you don't mind, let me write theta squared first. And then I have x, which is tan theta. And then instead of dx, I write secant theta squared d theta. And of course, I want to use integration by parts to calculate this integral. And you see that this is a polynomial function in theta of second degree. So hopefully you realize that you have to do integration by parts 2 times. Okay, so I will use the formula of integration by parts. Integral u dv is equal to uv minus integral v du. And I give the role of u to this expression, and I give the role of dv to this. Okay, so u is equal to theta squared. I need to know du, so I differentiate both sides, so it becomes 2 theta d theta. And I have v equals to tan theta secant theta squared d theta. Oh, sorry, this is not v, this is dv. Okay, in order to find v, I have to do a little bit of integration as well, very small one. So v is a primitive function of this. So tan theta secant theta squared d theta. So in order to do this integral, I introduce a variable. So let me call this one, let us say capital T. If this is capital T, then secant theta is the derivative of tangent, so then definitely this becomes dt. So the integral is simple. It becomes just simply 1/2 t squared, because this integral is t dt. And t is this guy, so this becomes 1/2 tan theta squared. So now I have everything I need. So I go back and write the formula. So I becomes equal to u times v. This is my u, and this is my v. If I multiply them, it becomes 1/2 theta squared tangent theta squared. And then minus integral v, this guy, times du. So you see a factor of 2 here and a factor of 1/2 there, so they cancel out. So this becomes integral of theta tan theta squared d theta. Okay, so that is what I have to calculate now. But to calculate this one, which I will give it a name j, I introduce this to be u this time. I want to use integration by parts once more, and then I want to give this the role of dv. Okay, so what should I write now? U is theta, so simply du is d theta. Yes, and then dv is tan squared theta d theta, I want to find v. So if you don't mind, let us do a little bit of simple integration here to find this integral. These are, of course, very standard and famous integrals. Hopefully you know how to do that. Instead of tan squared, you write secant theta squared minus 1. This is the formula, trigonometric formula, d theta. And this integral becomes the integral of the first one, but that becomes just simply tangent theta, because the derivative of tangent is secant squared. And integral of minus 1 is just simply minus theta. And of course, I will put an overall constant at the very end. So this is v. Now, integral that I call j can be written as u times v. This is my u, that is my v. If I multiply them, so it becomes theta tangent theta minus theta squared. And minus integral v, which is this, times du. So that's simple. Okay? But what I can do, I can break this integral into two integrals. So this becomes theta tangent theta minus theta squared minus integral of tangent theta d theta, and then minus minus plus integral of theta d theta. Okay, so this is extremely simple. The answer is 1/2 theta squared. But this is also a standard integral. If you have forgotten, I can just do it here for you. So instead of tangent, I can write sine theta d theta over cosine theta. So this is just tangent. And then I can introduce a variable, say beta here. The derivative of cosine is negative sine, so this becomes minus d beta. D beta, beta is ln, so it becomes minus ln of absolute value of beta. But beta is cosine theta, so this becomes absolute value of cosine minus ln of absolute value of cosine theta. So finally, I found my j. It is theta tangent theta minus theta squared. And then instead of this one, I put that expression, but there is a minus sign here, so this becomes plus. And here, this becomes plus 1/2 theta squared. So this is my j. And now finally, I is this. I found j, so I replace j here, but be careful, there is a minus sign, which will change all the signs from negative to positive and from positive to negative. So let us just do that here. So I is equal to, I write the first term, minus, the first term becomes minus, the second term becomes plus, the next term becomes minus, and finally the last term becomes minus as well. And then of course it's a good place to introduce my constant c. So that's my I. But of course I have to switch back to my original variable x, so we would do that as well. So here of course I can simplify, but let us do it a little bit later. So theta and tangent theta doesn't pose any problems, because you see theta is this and x is this. So it is easy to replace theta and tangent theta to the old variable x. But let us do something here. If I go back there, when I introduce theta to be tangent inverse, so it means theta belongs to the range of the tangent inverse function. So it means that theta is in the open interval from minus pi/2 to pi/2. So in other words, theta is somewhere in the fourth or in the first quadrant. And in both cases, cosine theta is positive. Yes? So if cosine theta is positive, I really do not need that absolute value sign. Okay, on the other hand, this is not good because I want to switch back to my old variable, but there is a famous formula that we know 1 plus tangent theta squared is 1/cosine theta squared. This is a very famous trigonometric identity, but tangent theta, if you see, is x, so I put it here, so this becomes 1 plus x squared is 1 over cosine theta squared. So this means that cosine theta is plus or minus 1 over square root of 1 plus x squared. But as we learned before, the negative sign is not acceptable. Now everything is in order, so let's just write it down. So this becomes 1 over 2. Tangent theta is x. So let me write that one first. And theta is tangent inverse. Let me write that one later, okay? Here, like this. And then I will do the same thing here. This is x. This is tangent inverse x. And then theta squared minus half theta squared. It becomes half theta squared. But theta is tangent inverse of x squared. And here I would write minus ln of 1 over square root of 1 plus x squared. And then I have a constant c at the end. Okay, that's correct. That's finished. But let us just do some simplifications. So here, between this one and that one, I factor 1/2 from the left side. Okay. And I factor this term from the right side. Okay, from this one, x squared is left. From that one, 1 is left. I copy and paste this term here. And this one I can write plus 1/2 ln of 1 plus x squared, and then plus a constant c. What I have done here, so you know that ln of 1 over square root of 1 plus x squared. So let me take the minus sign as well. So I use this minus sign to swap these two. Yes. And then I can write it as 1 plus x squared to the power of 1/2. And of course, you know that 1/2 goes to the back. So this is why this expression is exactly equal to that expression. So this is my integral I, which we are supposed to calculate. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.